Mesos and Filamba estimated the length of a line to be 9 centimeters and 10 centimeters respectively. If the true length of the line was 9.6 centimeters, find A. Mesos' absolute error, B. Filamba's percentage error. Grace and peace to you, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Reviewed. Today's topic is on approximations, and under approximation we'll discuss errors. We'll discuss absolute error, relative error, percentage error, tolerance, and upper and lower limits. Okay, let us discuss these things before we answer questions. Okay, so we are talking about errors. And the first thing we'll discuss is absolute error. So what is absolute error? Absolute error is just the absolute difference between true value and recorded value or estimated value. This is the absolute difference between a true value and recorded value. So absolute error is equal to the absolutes. Then we have true value minus recorded value. Okay, so if you see the absolute, it means even if you get a negative there, you will just get a positive value. So absolute error is the absolute difference between a true value and recorded value. So we use this formula when we have true value and recorded value. When you have two things, you have two measurements, the true value and what was recorded. Then you can use that formula: true value, the absolute of true value minus recorded value. Now there are cases where you have just one value, the recorded value. In this case, absolute error, that is if we have just one value, absolute error is equal to least unit of measurement, divided by 2. Least unit of measurement divided by 2. If the measured value is a whole number, then the least unit of measurement should be 1. If the measured value is as 1 decimal place, then the least unit of measurement should be 0.1. If the measured value has 2 decimal places, then the least unit of measurement should be 0.01. That is according to the number of decimal places. So the position of 1 depends with the number of decimal places. Okay, so if it is a whole number, it's just a 1. If it is a 1 decimal place, you get 0.1. If it is 2 decimal places, you get 0.01. So that's about the absolute error. If we have one value, you have just the measured value. So it's this unit of measurement divided by 2. If you have a true value and the recorded value, the formula is the absolutes of true value minus a recorded value. Okay, then the other thing is relative error. So relative error, this one is equal to its absolute error. Its absolute error divided by, this one is just a ratio, absolute error divided by true value. That is the relative error, and usually it is written as a fraction, so you just simplify the fraction. Okay, then the other thing is percentage error. The percentage error is just equal to just relative error. Just relative error multiplied by 100. That is percentage error. Relative error multiplied by 100. That is percentage error. or relative error is absolute error. So it's absolute error over true value then times 100. That is, if relative error is not given, you use that formula, absolute error over true value times 100. That is for percentage error. Tolerance is equal to, this one is just absolute error times 2. Absolute error times 2, or upper limit or upper bound, upper limit minus lower limit. So these are the formulas which we need to understand for you to know approximations are better. Okay, let's go to the questions now. So first question there, we have Missos and Filamba estimated the length of a line to be 9 centimeters and 10 centimeters. So 9 centimeters, it is Missos's, then 10 centimeters, it is for Filambas. If the true length of the line was 9.6 centimeters, find Missos's absolute error. So here we have two values. Missos measured or estimated the length to be 9 centimeters, and the true length of this is 9.6. So we'll say A, that is 1A, absolute error is equal to, so we have a true value which is 9.6 centimeters, 9.6 centimeters minus recorded value which was 9 centimeters. Okay, so the difference of 9.6 and 9 is, yes, you get 0.6. So we have 0.6 centimeters. That is Missos's absolute error. B, Filamba's percentage error. So again here, you cannot just go straight to percentage error minus calculating absolute error. So first thing, we need to know the absolute error for Filambas. So absolute error is equal to true value here is 9.6 centimeters minus the recorded value, estimated value was 10 centimeters. So it's 9.6 centimeters minus 10 centimeters. So if you get a difference there, you will see that it will be a negative 0.4. Now, because of these absolutes, you get it, as a positive value. So it will be 0.4 centimeters. So that is the absolute error for Filambas. Now we are solving for percentage error. And we know that percentage error, therefore, percentage error is equal to, we have absolute error, which is 0.4, over a true value, which is 9.6, times 100. Okay, so here we can simplify the fraction. We know that here we have decimal places, so we need to get rid of decimal places. Okay, so there's one decimal place and one decimal place. So the highest decimal place there is just 1, so you multiply by 10. If we had two decimal places, we would have multiplied by 100. If it was 3, 1000. Okay, so the highest number of decimal places there is 1, so you multiply by 10. So 0.4 times 10, you get 4, over 9.6 multiplied by 10, you get 96. Then you multiply by 100. Okay, now let us try to simplify the fraction. Okay, can 4 go in 96? Yes, we say 4 in 4 is 1. Then 4 in 96, we know that 4 in 9 is 2, remainder 1, and 4 in 16 is 4, so that is 24. So 1 over 24. Then there is 100 there. We'll say 24 in 100. Okay, we'll try to simplify it again. So we'll say, okay, what is 24 in 100? 24 times 4 is what? 24 multiplied by 4, you get, this is 9 times 4 times 4, that is 16, carry 1, that is 8 plus 1, 96. Okay, so you get 24 in 100, that is 4. Then there is a remainder of 4 again, then over 24. So 24 in 100, that is 4, that is 96, remainder 4, so it's 4 over 24, then percentage. Okay, so this is equal to, we simplify the fraction there, 4 in 4 is 1, 4 in 24, you get 6. So we have 1 over 6 percent. So that is the percentage error. We go to number 2. A bag of potatoes has a mass of, we have 15.4 plus or minus 0.05 then kg. So if you see a plus or minus and the number there, it means that is the absolute error. That is absolute error. So the 0.05 is the absolute error. Okay, find the tolerance of this mass. So without wasting time, if you are solving for tolerance and we have absolute error, that's multiplied by 2. So we say tolerance is equal to absolute error times 2. The absolute there is error there is 0.05. So 0.05 times 2, and 0.05 times 2 you get what? 0.1 kg. 0.1 kg. So that is the tolerance. Write down the relative error of the mass as a fraction in its simplest form. Relative error, and we know that relative error is equal to absolute error divided by true value. So this is equal to absolute error is 0.05 over a true value, that is 15.4. So over 15.4. Again here we simplify the fraction, so we can see that we have 2 decimal places there and 1 decimal place. So the highest number of decimal places is 2, so we multiply by 100 to both the numerator and the denominator. So 0.05 multiplied by 100, you get 5, over 15.4 multiplied by 100, you get 1440. Okay, so now you just simplify the fraction. So 5 in 5 is 1. 5 in 15, you get 3. 5 in 4 is 0. Carry 4. 5 in 40, you get 8. So it's 1 over 308. So that is the relative error. We go to number 3. Question 3. The mass of a bag of mealie meal is 25.3 kg, measured correct to 1 decimal place. What is the relative error? So we cannot go straight to relative error if we don't have absolute error. So first thing is to find the absolute error. So you say absolute error is equal to, we need to have least unit of measurement, least unit of measurement divided by 2. So the least unit of measurement here is, we can see that we have 1 decimal place. So for 1 decimal place, least unit of measurement should be 0.1. So it's 0.1 divided by 2. And 0.1 divided by 2 you get 2 in 0 is 0 point, 2 in 1 is 0, you add a 0 to 1, so you get 2 in 1 is 0, you get a 0, then you add a 0 to 1, so 2 in 10 you get 5, so it's 0.05 kg. That is the absolute error. Now we are looking for relative error, so therefore relative error is equal to, so we have absolute error divided by a true value. So the absolute error is 0.05, then divide by a true value, we have 25.3. So we simplify the fraction, so we can say that we have 2 decimal places there and 1 decimal place. So the highest number of decimal places is 2. So you multiply by 100 to both the numerator and the denominator. So 0.05 multiplied by 100, you get 5, over 25.3 multiplied by 100, you get 2,530. Again, you just simplify the fraction. So we say 5 in 5 is 1, over 5 in 25 is 5, 5 in 3, that is 0, then you put a 3 to 0, that is 30, 5 in 30 you get 6. So we have 1 over 506. That is the relative error. We go to the last question. Find the percentage error of the mass of a bag of sugar that weighs 10.00 kg, correct to 2 decimal places. Again, here we start with absolute error. So we say absolute error is equal to, it is least unit of measurement divided by 2. Least unit of measurement divided by 2. So we can say that this one has 2 decimal places. So if it is 2 decimal places, the least unit of measurement should be 0.01. Then divide by 2. Okay, so absolute error is equal to, so we have 2 in 0 is 0, point, 2 in 0 is 0, 2 in 1 again is 0, then you add a 0. 2 in 10 is 5. So we have 0.005. That is kg. That is absolute error. So therefore, percentage error is equal to, we have absolute error over true value times 100. So this is equal to, absolute error is 0.005 over true value, we have 10.00, then times 100. Okay, again here we have 3 decimal places and 2 decimal places. So to get rid of the decimal places, we multiply by 1000, because the highest number of decimal places is 3. So we multiply by 1000. So this number multiplied by 1000, you get 5, over 10 multiplied by 1000, you get 10,000. Then multiply by 100. Okay, now let us simplify. So here we can just cancel out 2 zeros and 2 zeros from 10,000. Then you say 5 in 5 is 1. 5 in 100, that is 20. So you get 1 over 20%. That is the percentage error. So this is how you perform calculations to do with approximations, particularly errors. Thank you so much for your time.